Beer-Lambert's law is extremely important for this experiment. Beer-Lambert's law states that absorption of a solution is equal to epsilon times the length of the solution the light passes through times the concentration of the solution. Epsilon in this equation represents the molar absorption coefficient of the solution. Absorbance and concentration are directly proportional, so typically the higher the concentration of a solution, the higher the absorbance that solution will have. Failing to zero a spectrophotometer before using it could alter the results of your data. To start this experiment, students had to fill cuvettes with a stock solution, dilutions of the stock solution, and a solution which would act as a blank in the spectrophotometer. After preparing the cuvettes, students must wipe two sides of each cuvette before putting it into the spectrophotometer. Here, students are wiping the blank so that they can zero the spectrophotometer before scanning all wavelengths in order to find the lambda max. After zeroing the spectrophotometer, students then clean the cuvette of the stock solution before putting it into the spectrophotometer and scanning across all wavelengths in order to find the lambda max, which will then be used in a different program to more accurately and quickly measure the absorbance of each dilution of the stock solution. It is important to scan across all wavelengths when starting this experiment in order to find the lambda max. Once the lambda max has been found, it can be used to scan at only that wavelength. This will improve the speed and accuracy of your test results. In this experiment, our lambda max was 603 nanometers. After determining the lambda max, students then switch to a different program, zero the spectrophotometer again, and then complete scans at exactly the wavelength which is represented by the lambda max. Students will do the scan for the stock solution and for each dilution of the stock solution which they have, making sure they record the results of each trial. It is important that students make sure they put the clean sides of the cuvette in line with the beam of the spectrophotometer. It is also important for students to make sure that they close the door of the spectrophotometer after putting the sample in and after removing the sample. At the end of the experiment, students clean up their own stations and dispose of all the solutions properly.